is 3. The last one, the -4 is being raised to the -2nd power. So that's going to be 1 over -4 to the 2nd. The -4 does not become a positive. That rule is only for the exponents. This is 1 over positive 16. When you multiply things that have exponents, what do you do with the exponents? Add them. Yep. So this is b to the m plus n. This one, instead of having a b or an x there at the bottom, you've just got a 3. That's the same thing. That's 3 to the x plus 5. This next one would be 2 to the 3 plus 2, but we can simplify that further. That's 2 to the 5th. You got 2, 4, 8, 16, 32. 2 to the 5th is 32. And yeah, this is still the same thing as 2 cubed is 8, 2 squared is 4, 8 times 4 is 32. That's just showing those exponent rules. Next one would be x to the 6 minus 2, which is x to the 4th. And then these last two are going backwards. So when you have exponents that are being added, this is the same thing as having x cubed times x to the y power. So what would this one be? Yep, 4 to the x times 4 squared, which is really 4 to the x times 16. And I'm going to rewrite that like this. So just two different ways to write that. This is kind of in my exponential form. We talked about a times b to the x. You'll see it written like that. The power property, if you have like an exponent to an exponent, what do I do with the exponents? Multiply them. So this is really b to the m times n. The next one will be x to the 5 times 3, which is really x to the 15th. The next one would be 2 to the just xy, x times y. This one would be 2 to the 2 times 3 power, which is 2 to the 6. Just up here we knew 2 to the 5th is 32. So multiplying that again to get 2 to the 6 would give me 64. This one would be 2 to the x times 3, but you're probably going to see that as 2 to the 3x, because x times 3 is 3x. And then this last one would be 5 to the 1/2 x, 1/2 times x. You might also see that as 5 to the x over 2. 1/2 times x is the same as x over 2. The thing that's going to be new probably to you, when you have fraction exponents. So this says the k root, like we have a square root, a cubed root, a fourth root of b. That's the same thing as b to the 1 over k. So when you have a fraction exponent, fraction exponent, the denominator is your root. So whatever the denominator is, if it's a denominator of 2, you have a square root. A denominator of 3, if your exponent's a fraction, that denominator is 3, it's a cubed root. So for example, this next one, this is the 6th root of x. That's the same thing as having x to the 1 over 6 power. If you, I'll show you an example in a minute. This one is y squared underneath, but it's a cubed root. So this is y to the 2/3. So b to the 1/3 is the cubed or the third root of b. How would I write the cubed root of 8? Oh, never mind. How would I write 8 to the 1/3? The cubed root of 8. This would be the cubed root of 8, which is what? You may know? 2. Yep. Because 2 times 2 times 2 is 8. 16 to the 1/2 would be the what? Square root. Yep, the square root of 16, which is 4. Yep. In your calculator, if you do 16 to the 1/2 power, you get 4. Square root of 16 is 4. Yep. So, look what we're going to do again. We're going to try to do this better this time. Transformations, our favorites. Using the exponent rules. Okay. I'm going to try to get it this time. Horizontal translations. You are not going to see the words shifted left, shifted right on your AP exam. They have told us it will say horizontal translation. Horizontal, you know, goes this way. That's left and right. Okay? Those happen. So I'm going to, all of these examples, our original function is 2 to the x. So we are looking at how we're changing 2 to the x power. So a horizontal translation. When everything, everything on this side affects your x values. Okay. A horizontal translation, left and right, affects your x's. Everything that affects the x's is opposite of what you would normally think. So, 2 to the x plus 4. Notice I'm adding 4 straight to the x. It's different than this one over here because that plus 4 is added at the end. This plus 4 is right with the x in the exponent. Now it says plus 4, but it's really the opposite. This is a horizontal translation of -4 units, which does mean it goes left 4. But those words are not going to be there on your AP exam. These types of, well, I take that back, I don't know that for sure. Most of these examples you're going to see in multiple choice. It would say a horizontal translation of -4 units. This right here, this 2 to the x, the point 1, 2 is on this line. Or on this is exponential, it's not a line, but on this curve. So if I start with the point 1, 2, I'm going to see how that point changes. Every one of these, something changes to your x. Okay? Since it's a horizontal translation of -4, we're going to subtract 4 from the x. And I would get -3, 2. And let me show you. If I plug in a -3 for x here, my answer, I should get a 2. 2 to the -3 plus 4 is 2. So this point is on my original. 2 to the first power is 2. -3, 2 is on my new one. Now this one is 2 to the x minus 4. That is a horizontal translation of 4 units. So even though it says -4, we do the opposite. It's +4. It goes right 4. So I am going to take 1, 2, and I'm going to add 4 to the x. And it would become 5, 2. So horizontal, left and right, your x values go left and right. X's are always opposite. Vertical translation goes up and down. That's your y's. Y's are not opposite. So when you see, and notice this +4 is at the end. It's after. So this is a vertical translation of 4 units. So it's +4, it's up 4. Positive 4. But this is going along with your y's. So when I add 4 on this one, I'm adding 4 to the y's. So the point 1, 2 becomes the point 1, 6. If I plug in a 1 for x, I get 6. And then this one would be a vertical translation of -4 units. So it would become 1, -2. Questions? Reflections. Reflections happen when there's a negative. That negative is either going to be in the very front or it's going to be right with the x. If it's right with the x, it reflects on the y-axis. That's kind of where your opposite comes in. If it's right with the x, it's y-axis. So this is a reflection across the y-axis. But that changes your x value. If you think about if you jump across the y-axis, your x value you go 2, 3. If you reflect across the y-axis over here, this is negative 2, 3. So your x value is the one that changed. Your y value, it didn't go up or down any, it stayed the same height. So the point 1, 2 becomes negative 1, 2. And then the x-axis, when you have a negative in the very front, that's a reflection across the x-axis. The point 1, 2 becomes what? That one's negative 1, 2. So this one's going to be 1, negative 2. If you jump across the x-axis, your x stays the same, your y changes. Now, dilations. You don't have to know, is it a shrink or a stretch? That's not going to be on there. It's either going to be a horizontal dilation or a vertical dilation. Horizontal, if you got a number being multiplied straight to your x. Notice the difference here. This is x plus 4. This is really x times 3. 3x is x times 3. Dilations come in when you have a number being multiplied right in front of your x, and they're opposites. So this is a horizontal dilation, and then we give a scale factor. We would say with a scale factor of 1/3. So when you think opposite here, it doesn't become negative 3, it becomes 1/3. So a horizontal dilation, I know it's horizontal because that number is with the x, and the scale factor. With dilations, you tell a scale factor. If you say a horizontal dilation of 1/3, that's fine. I'm trying to use what terminology I think you will see. All right. So the point 1, 2, we multiply that scale factor by the x. So 1 times 1/3 is 1/3, 2. And the second example is still a horizontal dilation because the x is being multiplied by 1/5. So I would say it's a horizontal dilation with a scale factor of, what do we think this one's scale factor is? positive 5, yep. 1 over 1/5. If you do 1 over 1/5, it's 5. Oh, you can't see that. Yep. So that means this is still horizontal. So x, I'm going to multiply my x by 5. And we get 5 too. Vertical dilations. Do you see a difference in these two problems? The horizontal to vertical. The difference is where the 3 is located. In horizontal, the 3 is up in the exponent with the x. Vertical, it's when it's in the front. So this is 3 times 2 to the x. So that's what makes it a vertical dilation. So it's going to affect your y's. Y's are not opposites. So with a, I'm just going to put SF, scale factor of 3. You don't change, the scale factor is what's being multiplied. In vertical y's, it doesn't change. Horizontal x's, it does. So the point 1, 2 in vertical, this affects my y's. So this point is going to become the point 1, 6. Vertical dilations, you multiply by the y's. And then the last one, vertical dilation with a scale factor of what's my scale factor? What? 1/5. On the verticals, it's you don't change it, just the horizontal. So 1/5. So the point 1, 2, we're going to multiply the 1/5 by the y. So 1/5 times 2 becomes 2/5. The good thing is that a lot of the things that we first saw in Unit 1 show up again now. So we're going to go back to these transformations and hopefully we will all, me included, get them right this time. And then that'll just help you kind of build on that. Same thing, you've seen increasing and decreasing again. You've seen concave up, concave down again. So those keep showing up. So the cool thing, I don't know, you probably won't think it's cool, is because of our exponent rules, when we're talking about these exponential things and these exponent rules, they can be written, we can rewrite things using our exponent rules. And so our transformations kind of act a little weird. So just transformations affect the x's or y's? The x's. Okay. So we just saw a horizontal translation. We did some of those. That's when I have a number added or subtracted with the x. In this case, it's the exponent. And I also showed you some exponent rules. So let's go think back to the front page. I put this exact problem on the front page as what's right here. 4 to the x plus 2. How did we rewrite, using those exponent rules, 4 to the x plus 2? What was my next step? How did I get to the 16? 4 to the x times 4 to the second, which we know is 4 to the x times 16, which is really 16 times 4 to the x. So the exact same problem that looked like a horizontal translation, it looked like, because I added to the x, that's left or right. Just using exponent rules, I can move it around. This looks more like one of these problems, doesn't it? The number being multiplied in the front. Looks like a dilation, a vertical dilation. So, every horizontal translation of an exponential is the same as a vertical dilation. Just using your exponent rules, you can take something that looks like it moves left or right, make it look like I've dilated it. I've stretched it. So, we have 3 examples. All of these examples are adding something in the exponent, and they show a translation. Adding to your x is a horizontal translation. We're going to use our exponent rules, just like we did up here, to rewrite them and make it look like a dilation. So 2 to the x plus 3. How would I rewrite that using my exponent rules? Yep, 2 to the x times 2 to the third. Those 2 lines are exactly the same. And I know that 2 to the third is what? 8. So 2 to the x times 8 can be written like this. Just moving the 8 to the front. If you're multiplying by 8, you can move it to the front. That's no big deal. Like 2 times 3 is the same as 3 times 2. So I'm going to put f of x equals. So those 2 functions are technically exactly the same. If I made a t-table and plotted all the points, my t-table would look exactly the same. Let's see. 2 to the x plus 3, 8 times 2 to the x. It's annoying. Better than what I opened my calculator up to this morning. Somebody had typed a word in that I'm not going to say out loud. So, you didn't really get to see it, but it did the blue line first, and then the red line went literally over top of it because they're exactly the same. The x minus 2. How would I write that one? Close. 3 to the x. If it was 3 to the second, that would be x plus 2. Negative second. Which is really 3 to the x. What's 3 to the negative second? Yep. 1 over 3 squared. which is really 1 over 9. You keep simplifying everything you can. Don't leave something as 3 squared when you know that's 9. Okay, and then this is technically not wrong, but you're gonna see everything written like this. Your A is first, and then your B is in parentheses with the X. So this would really be 1/9 times 3 to the X. Gosh. So let's try this one, changing this up. 3 to the X minus 2, and then 1/9 times 3 to the X. So there goes my blue line. That's what it looks like. And then notice my red line, I don't know if you can see that, is going right over top of it. Okay. So if you have a calculator and you want to check, you're like, I don't know if I did that math right, that would be an easy way to check. Graph them and see if they overlap. Okay. Number 3, this is 4 times 3 to the X times 3 squared. Which is 4 times 3 to the X times 9. Is there anything else that I can multiply together? The 4 and 9, those are just numbers. You go ahead and multiply those. 4 times 9 is what? 36. So this is 36 times 3 to the X. We're going to do these last 2 here, and we'll save this tough back page for tomorrow. So let h of x equals 2 times 16 to the x over 2. Find h of 1. We're just plugging in a 1 for x. So h of 1 equals 2 times 16 to the 1/2. I want you doing this without a calculator, so I don't want you just typing that in. What does 16 to the 1/2 mean? How did you get 4? When you have a 1/2 power, that means the square root. A 1/3 power is the cubed root. Okay, so this would be the square root of 16. Which is 2 times 4, which is 8. Number 5 does not work out. We don't work it out to a whole number. You're working ahead and are confused. So h of negative 2 is 6 times 2 to the negative 2/3 power. But you never, ever, ever want to leave a negative anywhere. So the first thing I've got to do is get rid of this negative exponent. Negative exponents move to the bottom. You're bad, you're negative, you move to the bottom. So this is 6 times 1 over 2 to the 2/3. So if you got a negative exponent, fix that first. And then if you have a fraction exponent, fix that. Make it look like a root. So the denominator kind of comes out and becomes a root. So this is 6 times 1 over. So that 3 comes out, and I'm left with the 2 squared underneath. The 2 just kind of stayed there in the exponent. And I can fix that. I can make 2 squared into a what? 2 squared? 4. So cube root of 4. That's where your final answer needs to be. The cube root of 4 is not something you can get. It's not a whole number, so we would just leave it. And then the 6 can move into the numerator. So that was a lot. We'll stop there.